on home the final exam, if the z is negative, reminder, if the z is negative, you multiply, you get a negative, and therefore you have to subtract. Reminder, a z-score, a small z-score tell you is a negative z-score tell you is below the mean, a positive z-score tell you that is above the mean. And the z-score of 0, like we have up here, the z-score of 0, like we have right here, it just tells us that we are the mean, we at the mean. We are not above, we are not below, right? So that's what we have is, again, you either convert to the z-score or you either take the data, find the data, right? And let's take a look at the z-score. What is the importance of the z-score, right? What is the importance of the z-score? So this is what the importance of the z-score, and if you remember, I told you, I asked you if I'm taller or LeBron James taller, right? But again, look at this thing here. A student scored 56 on a geography test and 54 on a math test, right? The geography test have the mean of 80 and the standard deviation of 20. The math tests have the mean of 78 and the standard deviation of 30. If the data for both tests are normally distributed, meaning bell-shaped curve, which test did the student score better relatively to the class average, right? Relatively to the class. If you look at this thing here, like I mentioned, obviously, right? Obviously, 56 is higher than 54. Yes, obviously, that geography test score is higher than the math test. But relatively, right, relatively to the class average, to their class, to their respective class, which one is better, right? Which is, again, looking at this thing here, this is why we convert to the z-score, which is, again, as you can see, the data minus the mean, 56 minus 80 to give me negative 26, divided 20 to give me negative 1.3. Which is, as you can see, looking at this thing here, again, y is negative, which is, again, the average is 80, and this student scored 56, which is way below the average, right? Is 26 steps below the average, right? And again, that's why we have negative 1.3 as a z-score. And again, we have to convert the z-score for math, which is, again, 54 minus 78 divided by 30, which is, again, looking at this thing here, we have a negative 0.8. Remember, the bigger the negative, the worse the score, right? The bigger the negative, the further away you are from 0. So looking at this thing here, everybody see that the students score 56 on geography based on their respective class, respective test. 56 is worse than 54, right? Again, looking at this thing here, the students score better on the math test based or relatively to the class, right? So again, relatively to their score, relatively to the class, 54 is better. Again, yes, is obviously it's not, but again, relatively it is, okay? So that's what we have in the sense of a z-score. Z-score tell us that do we, whichever better z-score will have a better result, right? Relatively to their own category, okay? So similarly, right? Similarly, in terms of number 16, well, not similarly. Question with number 15. Again, number 15 is basically asked you to convert to the z-score, and from the z-score, we know which item have a better outcome relatively to their item. Okay. So number 16, which is, again, looking at this thing here, which is, again, like I mentioned to you guys earlier, on your final exam, there will be a chart. You have to click. They will say, click here for the chart. You can click there, and the chart will pop up. And once the chart is pop up, the chart is bigger than what I've been showing you guys. It's just that I have 0.5 in there. But again, it's that same thing usual. So let's take a look at this thing here. The first thing you have to ask yourself is, what are they asking us, right? reminder, this is what we want to do, is we want to sketch, right? We want to know which area underneath this curve, normal distribution curve, or they ask us, which is, do you agree that they ask us what percentage of freshman class have a combined SAT score above 1,110, right? Which is above, meaning anything on the right, right? If you were to turn this thing up, right side up, then you see anything above 110 is, above, right? So looking at this thing here, what do we need to do? Well, the table doesn't give you 1,110. The question asks you the Z-score, right? They give you the Z-score. So reminder, the first thing is we want to sketch to know which region are we looking for. Once we know which region we're looking for, now we need to find the Z-score. And how do we find the Z-score? Just like before, the data minus the mean divided by the standard deviation, which is, again, in here the data is 1,110 minus the mean, which is 1,000, divided by the standard deviation, which is 100, which is, if you do this thing here, you have 1.1. And as you can see, 1.1, your empirical rule, you cannot use it, right? Empirical rule is 1, 2, and 3, right? So looking at this thing here, we know that we're looking for the item to the right or above. So we go to our chart, and the Z-score at 1.1 is corresponding to the area or the percentage of 86.43 or 0.8643. Now the question is, my answer is the 0.8643. Is that your answer? Hopefully you guys say no. Why no? Because again, whatever the number in your chart is the item on the left side, right? We went over this last week. The item on the left side, which is in this case, because the item on the chart is on the left and we're looking for the item on the right, we have to take 1 minus that to give us 0.1357, which is, again, how do we interpret this thing here? We say that 13.57% of the freshmen have a score above 1,110 point on the SAT, right? So again, this is the idea, which is you need to ask yourself, which area underneath my normal curve do I looking for, right? If it's on the left, reminder, the answer is on your chart. If it's on the right, you take 1 minus whatever the area in the chart is. That will be your answer. And if it's in between, we take the 2 percentages and subtract among themselves. Right? And again, let's take a look at the last 2 problems. Number 17. One thing about number 17 is don't worry about it. Number 17, we did not cover this, and this is a little bit different concept. The margin of error, we did not cover this margin of error item, and the author way of explanation of this margin of error is very different from what you will learn in statistics. In statistics 2.203, Math 203, you will learn this margin of error, which is, for now, don't worry about this problem. You won't see this on the final exam. So number 17, just omit it, okay? So let's take a look at number 18. Number 18, this is the last problem we have here. And then I will see if you guys have questions. If not, we're done for this semester, guys. But anyway, let's take a look at number 18, which is, again, they say that the weight of the 12-month-old baby boy are normally distributed with the mean of 22.5 pounds and the standard deviation of 2.2 pounds, right? Find the percentage of the 12-month-old baby boy who weighs more than 25.8. And once again, more than, right? What is more than? Which is, reminder, more than is the item on the right. So if you know that we're looking for the item on the right, we know that we need to take 1 minus whatever in the chart. But for us to find the chart value, we need to find the